Welcome, everyone. Thank you for staying until the end of the day. It really means a lot that you all are here at the last session. Of course, nothing I talk about now is going to be more exciting than the QR code mirror maze. But I want to start this talk by talking about the least performant code I've ever seen in my career. So about 10 or 11 years ago, I was working as a consultant in the Boston area in the United States. I was embedded as a staff aug position in a local e-commerce company who was in the middle of completely rebuilding their customer-facing shopping application. You know, it's your standard browse products, add to cart, fill out payment details, submit the order, and then you get some clothes or shoes or whatever in the mail. Now, this company was completely rewriting their legacy app and this new shopping experience from the ground up. And brand new framework, brand new code, new tooling, etc. However, it was horribly unperformant. It could only handle 2 requests per minute. Not second, not millisecond, minute. And so the client, they were outraged. They had spent all this time and all this money building a flashy new version of their core product, and this was the performance they were getting out of it. And they were using extreme caching to try and help, but you can only get so far if the core of your system is rotten, right? So we set out trying to figure out what the issue was, using tools like Firebug and performance analysis, looked at timers, rudimentary metrics at the time, and eventually we found the culprit. It was the category menu. Now, not this exact menu. I wouldn't actually show the real client. I grabbed this off of some random Shopify page. But you get the idea. So the root of their performance problems was how long it took to render the navigation menu on their website. You see, just to render this menu required a very unreasonable number of database queries. Would anyone like to take a guess at how many queries it took to render something very much like that? Price is Right style. Feel free to shout it out. Anyone? 20? 200? Anyone else? 300. Going once, going twice. Sold for 200. It was 267 queries. That number is burned into my brain because I could not fathom how that could possibly happen, right? Every single page load trying to render that menu invoked 267 SQL queries. How would you write code like that? How could that even be possible? And you know, as we dove into it, there wasn't a single answer, of course. I mean, it was a variety of things. It was how the teams were structured. So for some reason, they had one team that was responsible for just what was the equivalent of like dealing with the appliances section. So they were responsible for that menu item. They were using a brand new tool, using an ORM that they were not familiar with, and so they were suffering heavily from N+1 errors, where they would pull up an item, and then, this isn't the exact code, but you get the idea, and they were trying to grab the item display name, which in turn would invoke another query. You know, not understanding the tooling, but most importantly, they had the wrong model. They constructed this rigid menu category domain structure that was linked together with a menu item thing, and it was the same domain entity in the code mirrored one-to-one to the underlying database structure. And they didn't intend to choose this wrong model. You know, they just dug themselves so deep that they kept going with adding more category and menu items and not stepping back to think about what a menu would look like. They dug themselves and they generated a bunch of accidental complexity in trying to render something as simple as a menu. And you know, I was flabbergasted why they never took a step back just to think about something like a more efficient way to accomplish a menu. And so that started me on a bit of a journey. That one moment, it was shortly after this, coming across this and helping them resolve their menu rendering, that I learned about and then became completely obsessed with the ideas of, I guess, non-traditional patterns, domain-driven design, command query responsibility segregation, and most importantly for today, event sourcing. And I say non-traditional because these aren't necessarily the ways that we learn how to do things in school, or the way frameworks teach us how to do things. They instruct us to build simple CRUD systems. But over the past decade, with these tools, for the most part, I've had a pretty stress-free development career. Building Spring apps on the JVM, rather than struggle with tacking on additional reports or trying to build audit trails, I get them for free. Rather than trying to run complex database migrations that take a long time or block customer experience or keep the app from being healthy, I just destroy the table and build a new one in the background, fully populated with historical data. In microservice environments, which we won't have time to talk about today, but if my systems can self-heal if they go offline for a bit and they can ask for the data that they missed while they were gone. My systems are generally fast and performant, able to absorb large volumes of writes and serve customer-facing reports handled by a single database query, though admittedly, eventual consistency can be tricky at times. And yes, these systems can be a little bit more complex to understand at first, much more so than traditional ORMs or CRUD systems, but doing it this way is vastly more valuable. And I'd like to share some of the details of how that is possible with you today. And so, at the root, the base of these techniques involve a data storage pattern known as event sourcing. My name is Steve. I'm from Boston, Massachusetts, in the United States. And I currently work for a startup called Stavvy, which is building applications to track legal operations and legal document ownership over time, and proving who is the current owner of a thing. And at the end of the talk, you'll see why this pattern is very valuable for our systems. So today, I want to go over the following: a small overview of event sourcing, make you aware of some of the trade-offs, and discuss some of the common criticisms that you might see. So far in this conference, I've mentioned to people, hey, I'm talking about event sourcing, and inevitably someone will mention a criticism. I'll talk a bit about what makes event sourcing systems very flexible, discuss some of our options as Spring developers, and then I've spent probably more time than I should have putting together a little demo for us to take a look at, and there'll be there's a GitHub repository if anyone wants to take a look after the show. So, this topic, event sourcing, what is it? Before I get into that itself, though, I want to set the stage a bit with how it compares to ORMs. And to clarify, when I say ORMs, or object relational mapping tools, I mean both the tool, Hibernate, Active Record if you're from the Ruby world, but I also use this term to describe the tendency for developers to directly map business logic entity to a single row in a database. Sometimes you might hear this called CRUD. And here in the sample code, for example, I have a method that wants to update an entity called foo. There's a foo repository, and I look up the foo, and I change the name, and then I save the foo. There's nothing inherently wrong with this code, but the problem in my mind is the fact that it's mirrored one-to-one, the entity to the row in the database. And so far, that may not seem problematic, but that's just one entity to one table. Things get a bit more complex if you add more. Here we have a relationship between a foo and a reservation. I'm reserving a foo. And it starts, and again, it seems relatively fine. I have my foo, I look up the current rate for a reservation, I look up the foo, if it exists, I use a cool builder pattern to set the rate, add it, build it, increment the number of times it's been reserved, and then I try to persist it. And so over time, that may be okay. I need to start making a reservations or a join table between the reservations and the foo if I'm stuck with the ORM model, and that's still probably okay. But eventually the business is going to come calling, and they're going to say, hey, we want to have a trail of all the reservations that have occurred, or we want to keep track of price usage and foo and the number of times a foo is used, and so. And I'm sure everyone here has been asked to build some sort of audit trail at some point. And you start tacking these things on, and you need to make sure that they all happen together. And so you start having a bunch of saves that occur within a single transaction, right? I need to save the foo, I need to update the reservation, I need to send something to the audit trail, mark a usage report, and it's starting to get a little dicey. Now, if anyone here is thinking, hey, wait a minute, why are you incrementing the number of times reserved that on the foo itself? Well, couldn't you just count the number of times the foo was used by a reservation in the database? And if that's you, you're halfway to event sourcing. And you may notice that, if I go back for a second, changing these tables as you go over time, and you add more, and you may have to start adding columns and shift things around. I'm sure everyone out there has struggled with complex database migrations, and the data model can get a little, I don't know if fragile is the right word, but you start dreading writing a migration or making a change. And it can start to feel that the underlying data entity, the underlying data structure, doesn't quite mirror what the business wants anymore. And you may, I know this has happened in previous jobs, you may start saying aloud to fellow developers, we should really go back and refactor this data model because it's not working. And if you have those feelings, you're not alone. And in fact, there's a term for this, and it's called the object relational impedance mismatch. This is a very fancy term that you can find on Wikipedia, and it basically says that we have these two great technologies, right? We have object-oriented programming, and we have relational databases. Each one is great, but you smash them together, and things start to go a little awry. And the reason for that is that you can see right there. Generally, a business entity has a life cycle and changes over time, but a relational database, in particular, is usually used for storing the current state of a thing, which doesn't exactly mirror the life cycle of a business. So if this problematic pattern that we've all been taught, that is demonstrated in every framework's how-to guide, yes, even Spring's, is there any alternatives? And that's where event sourcing comes in. And the basic premise of an event source system is that in such a system, we never run an update operation. Instead, we append immutable facts, called events, I lost my place. Immutable events to some central ledger of data, and that ledger grows over time as new things change in your system. Now, before I go on, has anyone here used an event source system before? Excellent. And I would be curious to see how your experience with it lines up to mine. If we have time, it'll be 10 minutes ago before the conference is over and we're done. But I'd be curious to hear your thoughts afterwards. To introduce event sourcing, I want to start small. So compare that previous update foo example with this, an event-sourced version of that same operation. Instead of mirroring, so here we have a foo, we have a name, and most importantly for an event source system, we track what I use the term agent, basically the person or the thing that is responsible for the change. So we first load the current state of the foo by using something called an event repository. And then we apply, instead of changing the name directly by accessing the name property or calling a setter, we apply an event to the foo, which has the new value that we're trying to change, name updated, and we pass along the agent, the thing or the person making the change, and then we save it. Now the key difference here is that instead of mirroring our foo entity to a foo table with a single row, we instead map the events that just were applied to that foo and stuff them into the journal. Now, an event is itself, and this is also an interesting thing that takes people a minute to grasp, an event is itself a class, a first-class entity within our system. I shouldn't say entity. It's a first-class thing within our system. It is immutable. It represents something that has happened, and you should always use a past tense name. And events have a common set of data no matter what they represent. We have the entity ID, the ID of the entity that this event directly affects, or has been applied to, or is the result of some action on that entity. The revision number, this is the sequence number of the entity's change. The agent, the user or system that caused that event to happen. And this is also an interesting thing I get questions about. 2 timestamps, one for time occurred and one for time observed. Occurred means when this event actually happened. and observed is when your system saw this event. Often, they were exactly the same. But sometimes, you will have, in a broader distributed system, you might have an event that occurred somewhere else, and your system is tracking it, and so you might need to know that, that this thing happened in the past, but you just saw it now, and you're adding it to the journal. And then a bunch of other data fields that are specific to that event. And so, when all these events are stored in the journal, it starts to look a little something like this. And again, instead of a single row, we have event after event after event after event after event. And that method that I showed earlier, load current state, it's grabbing from that event journal all of the events that are related to the particular ID of that foo. In this case, we have actually 2 foos in our journal at the moment, foo1 and foo2. We may have many, many more. And so what that slide was trying to introduce is that these events are linked to a single owned entity. These lists of events that are backed by this entity are called the entity's event stream, and each entity in our system is sourced from this event stream. So to see what user 100 looks like, I have to examine the entire history and load that from the store, sourcing the user from its event stream. To get the current state of any individual entity, we grab the stream, like I just said, and then basically you just apply. And each event has a revision or a sequence number on it, as we just saw. And as the entity, the reservation in this case, is mutated by that event, its version also increments to signal which sequence or revision number the revision's at. So it's fully possible to see what reservation number 123 looked like when it was at revision number 2 or revision number 3, even though the current value is at revision number 4. In code, it looks just like that. Use my event repository to grab all of the events for a reservation, and then just apply until I've done with all of the events in that sequence. And now my reservation is up to date and ready to be operated on. Now all of these events, all of the events for all of our entities are persisted into one central event journal. And in an event source system, this journal becomes the core of the system, the brain of the system, the trusted heart that everything else our system does comes from. This journal gives you a ton of benefits right out of the gate, right? If you talk to other folks who evangelize these types of things, they'll immediately say, it's the only system that doesn't lose data. And while that's true, it's not actually the most exciting bit to me, but what that means is, if I were to update, say, a user's email address in a traditional ORM-based system, I've updated the row, the column in their row, and whatever their previous email address was is lost. And so with this sort of system, I can see every user's email address that ever has been within that system. There's a built-in audit trail, so right out of the gate, my event source system doesn't have an audit trail as a sidecar or a tacked-on thing. The system is driven by that audit trail. Its main data store is that audit trail. It's impossible for the audit trail to be misaligned from the core system because the system is the audit trail. And that to us is the biggest advantage, because we have to prove legally that the owner of a document is what we said it was. We can keep track and show, hey, here's how we arrived at that decision, because we have that central event journal. Now, before I go any further, this is when people start looking at me a little funny. Setting up this structure is wildly different than anything that they've been used to in the past, and they start asking questions. Now, with any architectural choice, you have to trade something for the positives or the advantages that you gain. For every plus, there is a minus. Whenever I introduce someone new to event sourcing, they inevitably bring up several concerns, and it might seem like I'm dodging a little bit or hand waving, but rest assured there's answers to all the questions that you can come up with. I've talked with some of you out there already here at this conference and heard some very similar questions to what I'm going to show. Now, I should say that this talk is meant to be an introduction, to demonstrate how the pattern works. Think of it more like a 101 class at school. We could talk for hours about this pattern and various use cases, especially as you start getting more advanced, especially as you start to involve multiple systems. But I don't have time to go over all of them. I've only got 32 minutes left. I want to talk about the good stuff. So the first question I get is, this seems a lot more complex to handle even basic things versus ORM, right? And I should say that, yeah, there is a learning curve. This is not how we were taught in school or by the frameworks, and dealing with time is really hard. Thinking in a different dimension rather than just what's in the database now versus thinking about what's always been in the database means that you have to think about how you're working with these entities a little bit different. The basic flow, though, of an event source system versus an ORM-based system are very similar, right? The user is going to send a command or a mutation instruction to my server. I have to parse and validate that command. I have to load the entities from the database or load the events for those entities. I have to check that the requested mutation is valid. I have to update the properties or instantiate and apply events. Within a single transaction, I have to persist updates to the table, or within a single transaction, append a bunch of events to a single journal and then update some constraint support tables, which we'll talk about in a little bit. Respond to the caller and then perform side effects, like send an email or write to Kafka or publish an event. I should also note, people always say, hey, do you use Kafka for this thing? Kafka is a great way to share your log, but I would not use it as the actual event store, which we can talk about later if we have time. Next question, isn't it slow to read all of the events to load the current state, right? Do we really need to hold on? And do we really need to hold on to all the events? And the answer is, not really, and yes. So in theory, right, if you have an entity which has a good number of events that back it, then yeah, eventually you might want to perform an optimization such that you're not, say in this case, I had a reservation object that had 100 things that happened to it, and pulling 100 items out of my data store and then applying, has some I/O concerns. You might be thinking it's got some data transfer concerns and then some CPU concerns as I'm recalculating the state of the reservation. And those are valid concerns, but and then if it does become problematic, one method that you can do is create a snapshot event so that periodically you create a new type of event, which is basically saying, hey, I actually should make that 101 instead of 100, but you make another event that's the snapshot of all of the data on that reservation, and you plunk it as one giant event. And so then what you would do is search for a reservation's most recent snapshot, and it would say, hey, I'm at 95, and then you would only need to then grab the 5 more events and apply. So this is fully valid, and so if people have concerns about pulling the information out and thinking about and thinking that it might be slow to just do some quick CPU cycles, you can lean in this direction, but the trade-off is that you almost always have to do 2 calls to your data store. One to find that snapshot if it exists, and then the next one to then grab that secondary small batch of events. So you would only do this if you detected that it took longer to do the one on the left than it would take to do 2 database calls. And often, often you don't really ever do this because most entities don't change that often. I mean, how many times do you think a reservation will be affected? How many times is an order concept changed in an e-commerce system? How many times do you actually update your email address? But it would be important to add some metrics around to see how long it's taking to process a given entity so that you can know that, hey, it might be time to add some snapshotting. And to the second question about do we really hold on to the data, yes, you do hold on to every single event. And this is not a bad thing. Data storage is relatively cheap. And any data analyst that heard me talk about this would be drooling at the sound of being able to track every single change that has ever happened to the system forever. At having all of this data that they could then funnel into a data warehouse or a data lake, that they could throw into an OLAP store for analytical processing later. And then you as a performance engineer is going to love taking those events and putting them into dedicated customer-facing tables to handle specific customer queries. And by the time that storing all that data will eventually pay for it, will eventually pay for itself, any data storage costs that you might incur. What if the events themselves change over time? This is a great one I hear all of the time. What if they change? And yeah, they do. They can change over time. And it's pretty much like dealing with an HTTP API versioning. Furthermore, and I think with the real question, the harder thing is not so much that the events themselves change, but the internal domain changes over time. The events themselves start to take on a different meaning in your system now than they did, say, 7 years ago. And so that is the harder thing to think about, that your system has to be aware of, hey, I have this event from 10 years ago, 5 years ago, and when I see it, I have to realize what the business logic was at the time that the original event was created. It's not as hard as it sounds. Usually you can do it by making new versions of events. But that's another topic unto itself, a whole other presentation, and we don't have time to do that. Wait, you model the events as actual classes? Yes, you do. And it's actually really great. I can open up a file in my system, and I can see everything that I expect to happen within my system in one glance. It adds a bit of an overhead, the extra 5 seconds to add these data classes. Yes, we're going to be seeing a lot of Kotlin today. And the overhead it takes to just do this is absolutely worth the 5 seconds trade-off that, say, new engineers on your team, the advantage they get when they can just see at a glance what can happen within that system. How do we handle constraints? This is a big one. I cannot live without foreign keys. What about relations? You're putting everything in one big table? How am I going to know what foos are in that reservation? These are great questions. And so the first thing to mention is that anytime I do a mutation, I have to use the journal. I have to pull that reservation out of the journal, make sure that it's up to date, process the change, add the events, and then save it. But queries shouldn't use the journal. So while the event journal technically holds all of the information in my system, it's usually cost prohibitive to hold it all in memory at once, although you could. There's actually some really interesting architectures where up to a certain point, I just hold all of my event data in memory and then periodically flush to an event journal. That's another separate talk, but it's very cool stuff. Anyway, while we use the journal to build current state representations when we do the mutations, we typically create sidecar constructs, very much like join tables, to track relationships between separate entities. And I know this looks an awful lot like materialized views. I can also create, say, a table that is meant to serve just, say, the user order history page, and I work with the front-end team to see and the product team to see what they want the report to look like or the page to look like, and then I custom build a table for them, and then project the events from my journal into that table, creating a highly customized, ephemeral also, table for the user experience to view. And that sounds, again, like materialized views, but the trick here is that it's not based on other, like in a normal ORM system, a materialized view would be based on that current state static data. I can build all these arbitrary views based from historical data. And as for constraints, we can use those same mechanisms using that event history to track specific needs or purposes that we might need to handle business logic, like, say, email addresses. So if I'm handling user registration and I just have that big central event journal, I want to make sure that the email addresses are unique, right? That no one's actually using it. So what I can do is anytime I'm creating a new user and their events end up in the system, within the same transaction, I update also a user constraints query model, repository model, projection model, whatever you want to say. And then I can use that as, here, this user constraints repository that's checking is the email unique when someone tries to update it. And throws an exception or however you want to handle that error if the email is already taken. But if it's not taken, I generate an ID, and then it's off the side of the page, so you can't see it here, but then it generates some events, user created specifically, and then there's a call down below to actually persist that event journal. What if I make a mistake? Can I edit an event? No, never. Absolutely not. It's immutable. Don't even think about it, officially. There may be circumstances where you need to go back and, you made an oopsie. One classic case is, what if you put some customer information, sensitive information in an event, or you put a password in an event, or some other thing that you have to go back and change. Just don't tell anyone that you did it, but you could go back and and clean it up if you have to. You should be very embarrassed if you ever have to do that, though. Now, instead, if you make a mistake, like somebody put the wrong data or the incorrect calculation, or they made an error and they want to go back and change the event to the correct value, no, don't do that. You need to think like an accountant. An accountant would never scratch out an item in their ledger. Instead, what they would do is add new items to the ledger to correct the fact that something bad happened. So let's say, for example, that we were an e-commerce system and we shipped a customer order to them, but we realized we overcharged them. They get on the phone and they call us and they're like, "You charged me too much." Instead of going in and changing the event, what we would do is apply additional events that show that we made a mistake. So order cost adjusted, and then once we transmit the funds, we could do another event that says refund applied. This is actually, I think, much more valuable than just going in and updating the thing, because now we can see the history of how many times we've made a mistake, and we could go in and mine our event journal and be like, hey, how often are we adjusting order costs? How often are we sending refunds? By modeling that as a specific thing that happens within your system, you can do a simple query to grab time-based reports and frequency-based reports on when refunds are being applied. Let's see. Now, there's also an interesting scenario here in errors with things like optimistic locking. So let's say Bob and Alice are both trying to update foo number 100, and they both load it up, and they both are viewing the current data at sequence number 10. Now, if any of you have used other ORM systems, sometimes you'll see this. They have these things too, revision numbers or version numbers to handle optimistic locking. So Bob saves first, he wins. Now foo is at sequence number 12. Alice tries to save, and she gets an error because the journal's like, hey, wait a minute, you're telling me that you want to save this foo, but this foo is currently at a higher version. You can't do that. So it rejects the error. In an event source system, you can do some clever tricks sometimes where you can look at it and say, hey, what was Alice trying to do? Can the service rerun her command if a conflict was detected? Like, say Bob was changing the address of like a user's email address, and Alice was updating the name. Those are two independent fields. It might be okay if we want to allow that command to be retried automatically. But if it's not, you may have to prompt Alice again and have her reload the foo and then try again. And so that section number 1, that is very use case specific. In general, it's better just to kick it back. But there are some scenarios where you can automatically retry or program certain scenarios when they happen. Like, say, you're working for a company that does food ordering machines, and the server has a handheld device, and they go to your table, and you're ordering your steaks and your beers or whatever, and somebody gets up and pays the tab, and the other people at the table don't know that's been paid for, and they come up and they try to add another item to the order. That would come in as an event. It would see a conflict being like, hey, this system is in an invalid state. You can't order this beer because the ticket has been closed. You could automatically, if that conflict was detected, you could automatically say, spin up a new order and take the beer, and the person is happy as can be. All right, last one. Where would I use this pattern and where wouldn't I? Now, the problem with this question is that I'm too biased to answer it. I'm a bit of a zealot. I love this picture. It makes me laugh every time I see it. I suppose, realistically speaking, it's likely overkill for a system that has purely static data. Domain-driven design might call it value objects. If you have data that's not owned by your system, you might not want to do it there too. But what I find interesting, though, is that every mature business eventually ends up operating this way anyway. Like accountants, that's how they work. Advanced software systems operate this way. So your SQL server, your database system, has a transaction log underneath it that's tracking every single change that happens to your database. And every time I mention this, so usually somebody will come up to me and say, hey, we're doing something very similar to this at work. We never had a name for it until now. Okay, next section. So, why do all these systems and these companies eventually converge on patterns like event sourcing? And it's because of the flexibility that you get. First off, this inherent level of auditability that you get by having that giant central log is a huge help with error handling. being able to zoom forward and backward in time allows engineers to very easily look and to see how a given system ended up in the state it's currently in, right? You can see every single change that happened. You can go backwards, say an hour, and then replay the same events again to see what would happen, or what would happen if I applied a different event. What would happen within that system then? Every time I've introduced this pattern to teams that I've been on, there's always been a few folks that grumble and complain. This is hard. And once they get over the learning curve, then they sort of roll with it. And a lot of these people have later come to me and been like, doing this has really saved our asses. Being able to go back and look at the journal, rebuild a system. If I have an incorrect calculation, I can replay the events. It's fantastic. All right, anyway. The event log leads to deterministic systems. You may have used other tools or other situations that have made use of an event log or transaction log. Kafka comes to mind as having a giant sequenced distributed log of every event that ends up that you can use to communicate between two systems. But having that journal allows you to do a lot of really interesting things deterministically, like if an entity receives an event out of order, or if there's a gap in the sequence, that's very easy to detect and alert a user that something bad happened. An excellent test, or excellent integration or unit test for an event source system is to simply stand it up and then stream or replay an event journal with it and see if you end up in the exact same state that you were. But beyond error handling and recovery, I guess recall what I've been saying, that the current state of any given entity in an event source system is just the left fold, just the application of all of the events, of taking those events. But what if we took events from multiple entities and fed them into other objects? These other objects that aren't, strictly speaking, our entities or domain objects, but were instead query or report models that are calculated by looking at or using the events in a myriad of ways. We could then build all sorts, and I've been hinting at this, but we can build all sorts of new reports, new query models, new data stores, answer new questions, provide new lookups or search capabilities, depending on what our customers or the business demands. Let's see. But to do that, we need the ability to redrive or replay events through some observer or router. It's not as complicated, really, as it seems. You need some component that can then fetch events from your journal and then push them, ideally through some queuing mechanism, to some other observer that then takes your events, and then it might have these different repository objects or these query model objects that are registered with the observer and can take the events as they come in sequence and then update their internal models. And this, of course, should ideally be done asynchronously. And you can do it from the get-go, from the beginning of time. You could do it for like an hour, whatever works for your current needs. Or just a particular query. Like, it doesn't have to be all of the events. It could be all of the journal. It could be a particular set of events. Once we can do that, once we have the ability to replay, and we can do it reliably, then all of these supporting tables, they don't matter. If something's wrong, I can delete them and make a new object that represents rental usage report version 2 and throw the events through that. And we can keep going. At this point in our evolution, any ask that the product team comes to us with, or the business that has some new report that they want, we can generally say, "You got it, boss," and construct a new report model, redrive the events through it, and we're ready. And we have that report that has all the data, not just from when we started with that new report object, but since the beginning of our system's time. They will love you for that. And it's also highly performant. I can take the events, let's say I had a single mutation that was updating an order and a user and a bunch of products, rather than doing like 8 updates or whatever, I can take all of the events that are the result of this change and flush them in one save to the event journal. And then I can take those same events and then stream them over to some query model object that takes them and then updates or rebuilds a product revenue report in this case, I don't know, but is there specifically for some user experience that is looking directly at that table rather than the journal. And so, rather than doing 267 queries, I can do 1. Now, with all this together, this is why I brought up that very unperformant system at the beginning of this talk. Now, imagine how that menu could be built with this event concept in mind. One could stream events about high-level about all the products in our system to generate that menu. As new high-level product category items come online, an event could go through and the menu could be updated then. If a product is sold out, maybe I want to hide that from the menu. I don't even want to show it. If there's nothing in the warehouse or new things come back in the warehouse, I can listen for warehouse events and re-update the menu there. And the key here, I'm just rambling at this point because I got 11 minutes left. The key here is that over time, the underlying data models for your system may change and grow as your organization does. At one point, you might need document stores. At another time, you might need graph databases. At another time, you might need relational systems, et cetera, et cetera. But by only thinking in terms of classic CRUD data models, you may end up in situations where you've coded yourself into this rigid structure, and you end up create things like that old menu that I showed you. To keep extending that concept, though, and I'm still talking about these events based in a single system, this power, this flexibility gets extended even further if we start merging with event-driven distributed systems. I should reiterate, event sourcing is not the same as event-driven, but they go super well together if you decide to do that. We don't have time for that, unfortunately. That's a whole other talk unto itself. It's also possible to, as I mentioned earlier, to develop systems that are entirely in memory. Also don't have time to talk about that either. Trading systems, I think, do something similar to that. Anyway, another very interesting side effect of modeling your events as first-class things that within your system is that it starts to have this really interesting side effect that allows for more human collaboration. It makes developing a system more team-friendly and allows us to collaborate better. So two main techniques that I've seen that are directly related to this world are event modeling and event storming. I haven't actually done an event modeling session directly, but I have done a bunch of event storming. Has anyone else heard of event storming or modeling or used it before? Yeah. In each one of these approaches, you explicitly call out the commands and the queries and the side effects and the events that a user might see within your system. Now, what I like about these techniques is how they provide for cross-team collaboration. They allow non-engineers and then product folks and subject matter experts to all get in the same room and use, if you're familiar with domain-driven design, use the ubiquitous language to talk about what's happening within the system. And now your subject matter experts can contribute directly to what's happening. So they get up and they start putting sticky notes on a whiteboard. And this is due to how event modeling directly mirrors human thinking. Your SMEs will know exactly what you're talking about when you're using the same words for the events and the commands that the engineers and the subject matter experts are using. And it's great for actual in-person cross-team collaboration, and it's fun. You can do this online with a Miro or some other whiteboarding tool, and you can do it on a real whiteboard. And I've done these in meeting rooms, wall-to-wall whiteboards, snacks in the middle of the room, and you have people running around, and each section of the whiteboard is for a different scenario. It's fun. It's energizing. Okay, so let's say we want to develop our Spring Fs following an event source option or event source pattern. What options are available to us? What's out there? The main thing to be aware of here is that nothing I've described is proprietary tech or a tool. It's a pattern. It's a concept, an architectural choice. And most of what's out there is basically code that will provide adapters for you on top of different database technologies that turn them into event stores. When selecting a database, by the way, we need to ensure that they provide that ability to do a constraint on a combination of the entity ID and the revision number. That keeps things a lot saner. So in my career, I've used Postgres quite a bit. It has this neat ability to partition an event journal table by time, which is nice so that you don't get this giant table growing over. But once you get past that, and that becomes, and you outgrow that, I've used a lot of Dynamo systems. So Cassandra and DynamoDB are also great for this. Linearly scalable over time. Good, can't go wrong. And the frameworks that were there generally take on different levels of power or magic, depending on how you want to look at it. On one end, you have extremely powerful and in-depth tools like Axon. Axon is it's very, if you want to embrace the whole CQRS, command and query responsibility, lifestyle. Like it's neat. It handles all of that for you. It can deal. It can handle. It'll generate the event store for you. It can deal with distributed messaging. It can handle and allow you to model your commands and have event listeners, and it integrates very well with Spring. You also have tools like Eventuate, and Acco was the big name like five or 6 years ago. It has its persistence. Acco is a distributed actor model, but it has a persistence library that was entirely event sourced. And those are all great and fine, but I don't really think you should be using those until you have tried the pattern out for yourself. So on the other end, it's kind of how far down the rabbit hole do you want to go? How much magic do you want? On the other end, you can roll your own and do it by hand. Because again, it's just a pattern. And today, with the time I have left, I want to show you a little bit of an example of how you can do this, bare metal, with a simple Spring app and straight database access with Juke. And again, I would personally recommend, if you're curious about this stuff, trying that out yourself. And with that, let's do a little demo. So, first things first, I am going to mirror. Let's see if this works, please. Hey, all right. So I've created a little. Where did it go? Oops. It's here. Let's go back over here. So I have created a little GitHub repository, an event sourcing app that I called the Bike Shed, because developers love bike shedding. And so the idea with this app is that it's a management software that allows you to create reservations for bicycles. If you decide to go here later, I have a whole walkthrough of here's what to look for, some sections to dive into. As an example, I also have structured this a little bit more complex than I should have, and in fact, I call that out. Where do I say it? At first glance, so I created a multi-module project that tries to keep and does a lot of interfaces and stuff, and it's probably overkill for this demo, but I couldn't help myself. I apologize in advance if anyone's looking at this and they're like, oh, this is gross. It's mostly because of me and not the actual pattern. Just keep that in mind. Okay, so the core of the system is basically just a Spring app. I've got it running here in the background. It's too small. Can I enhance? Enhance. I've got a database running on the side, and let's say I want to see the list of available bikes. I can see that I have, well, that's embarrassing. Why did that not work? There we go. I have 4 bikes that are currently in the system. Red, green, and T100. I can also take a look at a particular bike, and I can see that this is a red bike purchased from the Bike Emporium. And I'm just making up words here, it doesn't really matter. But what's interesting is that because these things are backed by events, I can also do something and immediately show the user the history of the given bike. So I can see that, 3 months ago, the bike was added to the inventory by employee number 2, then it was rented out a month later, and then it was returned. Pretty neat. I can do the same thing with the bike T100. And this one is much more busy. I can see when it was added, I can see it was rented, I can see when it was returned, rented and returned. There's also some other events for things like repairs and things of that nature, but I don't have time to get into that. What this looks like on the data store, though, nope, there we go. Bike shed, yeah. Let's see, what are my tables again? So you can see that this system is doing a few things. Again, if I had more time, I'd walk into it. But whenever I make a change to one of these bikes, I reserve it or I rent it, the event journal gets updated, but then I have some additional supporting tables that are eventually asynchronously updated. Like, what are my available bikes at the moment? There's a 5th bike that you didn't see in that list because it's currently in for repairs. And I can look at the journal and see all of these things that I'm talking about from event journal. And so, again, this is a little bit like reading the Matrix, but you can start to see what's going on throughout the history of this system. So this is still not great, but as an example, I can see that bike ID T24 green at revision number 3 was returned by customer number 1, the timestamp, and then there's some, it's hard to read, but there's some data about the event. I'm going to skip over and actually show some code because that'll be easier to look at. So at the core of the system, this application is broken up into a couple modules. We have the core of the application, which is basically Spring, we have the app, which is basically Spring, the core of our domain, the core of our system, which actually contains all of our events and things of that nature, like I showed earlier, enhance. Bike returned, held for repairs, repairs completed. We have a version 2 here. I'm just rambling at this point. Let's see, but what's really interesting is this event source module. So in here, I actually wrote it in Java, but in here are some patterns or constructs that I've been using over the past few years that I found have been really helpful to better articulate what's happening within the system. So you'll notice that an event is just a public interface. There's nothing special about what's going on here. Now, you may have noticed, but Steve, there's a bunch of data that you said is on every single event. That's true. So there's also an event envelope. And the event envelope is a mechanism to encapsulate all of that supporting data, which you don't really want to deal with day to day when I'm constructing a new event, right? I don't want to instantiate an event and then have to be like, oh, what's the revision? Who's the agent? Instead, there's yet another construct, and again, things are getting a little bit more complicated. And yet another construct, and because I'm super good with names, it's called an entity with events. And it takes you give it an entity and the agent and the time that a system occurred, and it figures out what the next revision in the sequence needs to be. It generates the event envelopes for you. You just give it the events. So in code, what that looks like is, let's do a reservation quickly before I get booted off the stage. Reservation service. So here is a command for processing, you've opened up a new bike reservation and you want to add a bike to it. What does that look like? Well, first, I need to load the current state of the reservation from yet a new thing. It's called the entity store, which is helping dealing with the constraint projections. And again, not enough time. I encourage you to look at this later if you're curious at all about how this works. I then figure out if the reservation is allowed to edit bikes. Is it an active reservation? And are there bikes even available? If they're not, it should probably throw an error, but in this case, it's just returning an empty list because I didn't have time to do real error handling. We load the current state of all of the bikes in one query that the customer asked for, and then I filter out those that are not available to rent. I then create this entity with events concept, and then here is where the magic starts to happen. I add a new event. I'm saying, hey, bikes were added to this reservation. I'm also saying to the bikes, hey, these have been rented. And as long as the reservation exists and the bikes are available to be rented, this is able to progress. And then I grab all of the events from all of the entities that are currently in memory, take all of the events, and then persist that big mutation that could have been some unknowable number of bikes and reservation objects, persist it all in one save, and then return the entities to the user. So there's a lot more to uncover here. I am unfortunately out of time. The last thing I'll show just real quick is here's a simple event repository. There's a lot of comments if you're curious to read more about how this actually works. There's an example of how it works with just a simple juke construct. And you can see it's relatively straightforward. So if I want to load all of the events for a given ID, select from the event journal, by ID, order by revision, fetch, map to the actual event itself, and return to the user. And again, I apologize, there's a lot more to talk about, things like how I'm mapping the events to and fro, what an event alias is, but we don't necessarily have time at the moment. And with the time I do have left, because I'm already over, I want to leave you with a couple things. Basically, your domain model is not your data model. So if there's anything that you should take away from this talk, it's this. Do your best as you're building systems to not link your domain entity concepts, your business logic, to the rigid structure of your data. Keep them decoupled so they can evolve separately over time. We cannot predict the future, but we can prepare our systems for it. By having these things decoupled, it allows our system to adjust accordingly and avoid that object relational impedance mismatch thing that I talked about. With that, I'm done. Over time. Thank you all.